Okay, so our next chapter is observing the solar system. Have you ever gazed up at the sky on a starry night? If you watch for several hours, the stars seem to move across the sky. The sky seems to be rotating right over your head. In fact, from the northern hemisphere, the sky appears to rotate completely around the North Star once every 24 hours. Now think about what you see every day. During the day, the sun appears to move across the sky. From here on Earth, it seems as if Earth is stationary and that the sun, moon, and stars are moving around the Earth. But is the sky really moving above you? Centuries ago, before there were space shuttles or even telescopes, there was no easy way to find out. Earth at the center. When the ancient Greeks watched the stars move across the sky, they noticed that the patterns of the stars didn't change. Although the stars seemed to move, they stayed in the same position relative to one another. These patterns of stars, called constellations, kept the same shapes from night to night and from year to year. Greek observations. As the Greeks observed the sky, they noticed something surprising. Several points of light seemed to wander slowly among the stars. The Greeks called these objects planets, from the Greek word meaning wanderers. The Greeks made careful observations of the motions of the planets that they could see. You know these planets by the names the ancient Romans later gave them: Mercury, Venus, Mars, Jupiter, and Saturn. Most early Greek astronomers believed that the universe to be perfect, with Earth at the center. The Greeks thought that Earth is inside a rotating dome called the celestial sphere. Since geo is the Greek word for Earth, an Earth centered model was known as a geocentric system. In a geocentric system, Earth is at the center of the revolving planets and stars. About AD 140, the Greek astronomer Ptolemy further developed the geocentric model. Like the earlier Greeks, Ptolemy thought that Earth is at the center of the system, a center of a system of planets and stars. In Ptolemy's model, however, the planets move on small circles that move on bigger circles. Even though Ptolemy's geocentric model was incorrect, it explained the motions observed in the sky fairly accurately. As a result, the geocentric model of the universe was widely accepted for nearly 1,500 years after Ptolemy. So, this is that geocentric model. They talk about the planets moving in larger circles, so they're going around, but they are also moving in smaller circles as they go around the model. Sun at the center. Not everybody believed in the geocentric system. An ancient Greek scientist developed another explanation for the motion of the planets. This sun centered model is called the heliocentric system. Helios is Greek for sun. In a heliocentric system, Earth and the other planets revolve around the sun. This model was not well received in ancient times. However, because people could not accept that Earth is not at the center of the universe. The Capricorn Revolution. The Copernican Revolution. In 1543, the Polish astronomer Nicholas Copernicus further developed the heliocentric model. Copernicus was able to work out the arrangement of the known planets and how they move around the sun. Copernicus's theory would eventually revolutionize the science of astronomy, but at first, many people were unwilling to accept this theory. They needed more evidence to be convinced. In the 1500s and early 1600s, most people still believed in the geocentric model. However, evidence collected by Italian scientist Galileo Galilei gradually convinced others that the heliocentric model was correct. Galileo's evidence. Galileo used the newly invented telescope to make discoveries that supported the heliocentric model. For example, in 1610, Galileo used a telescope to discover 4 moons revolving around Jupiter. The motion of these moons proved that not everything in the sky revolves around Earth. Galileo's observations of Venus also supported the heliocentric system. Galileo knew that Venus is always seen near the Sun. He discovered that Venus goes through a series of phases similar to those of Earth's moon, but Venus would not have a full set of phases if it circled around Earth. Therefore, Galileo reasoned the geocentric model must be incorrect. Tycho Brahe's observations. Copernicus correctly placed the Sun at the center of the planets, but he incorrectly assumed that the planets travel in orbits that are perfect circles. Copernicus had based his idea on observations made by the ancient Greeks. In the late 1500s, Danish astronomer Tycho Brahe and his assistants made much more accurate observations for more than 20 years. They carefully observed and recorded the positions of planets. Surprisingly, these observations were made without using a telescope. Telescopes had not been invented yet. Kepler's calculations. Tycho Brahe died in 1601. His assistant, Johannes Kepler, went to work analyzing the observations. Kepler began by trying to figure out the shape of Mars' orbit. At first, he assumed that the orbit was circular, but his calculations did not fit the observations. Kepler eventually found that Mars' orbit was a slightly flattened circle or ellipse. An ellipse is an oval shape that may be elongated or nearly circular. After years of detailed calculations, Kepler reached a remarkable conclusion about the motion of the planets. Kepler found that the orbit of each planet is an ellipse. Kepler had used the evidence gathered by Tycho Brahe to disprove the long-held belief that the planets were moved in perfect circles. Modern discoveries. Today, people talk about the solar system rather than the Earth system. This shows that people accept the idea that Earth and other planets revolve around the Sun. Since Galileo's time, our knowledge of the solar system has increased dramatically. Galileo knew that the same planets that ancient Greeks had known, Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Since Galileo's time, astronomers have discovered 2 more planets, Uranus and Neptune, as well as Pluto, which is no longer considered a planet, but it is a dwarf planet, as you're going to learn in the future. Astronomers have also identified many other objects in the solar system, such as comets and asteroids. Today we know that the solar system consists of the Sun, the planets and their moons, and several smaller objects that revolve around the Sun. Galileo used a telescope to observe the solar system from Earth's surface. Astronomers today still use telescopes located on Earth, but they have also placed telescopes in space to gain a better view of the universe beyond Earth. Scientists have also sent astronauts to the moon and launched numerous space probes to explore the far reaches of the solar system. Our understanding of the solar system continues to grow every day. Who knows what new discoveries will be made in your lifetime? Awesome. That is our first chapter, Observing the Solar System. I hope this helped you today, and I do apologize about not being able to pronounce the astronomers' names. I'm hoping that you're able to pronounce them on your own.